All right, so starting with the first set of problems, it's asking us to determine how many and what types of solutions the following equations have. Show, work, and explain your choice for each one. So in this case, we're going to be using the discriminant, which is b squared minus 4ac. And based off of the value of the discriminant, we're going to determine how many and what types of solutions for each one. So first we need to identify a, b, and c, and then we're going to plug it into our formula. So it's going to be negative 4 squared minus 4 times a times c. And when we put this in our calculator, we end up with 0. And when our discriminant is equal to 0, we say that there's two identical real solutions. And that's because our discriminant is equal to 0. All right, the second one, identify a, b, and c, and we're going to plug it into our formula. So negative 16 squared minus 4 times negative 2 times 32. And we get 512. And since that's greater than 0, that means there's two distinct real solutions. All right, letter B. I guess I'm going out of order, but that's okay. So b squared minus 4 times a times c. For this one, we get 19, and that's greater than 0. So again, we have two distinct real solutions. So I'm using solutions and roots interchangeably. Either one is okay. All right, go ahead and doing letter E. So again, A, B, and C. So 3 squared minus 4 times A times C. We get 169. That's greater than 0. So we have two distinct real solutions. Number 3, or letter C, we have negative 9 squared minus 4 times A times C. We get a discriminant of 441, which means two distinct real. All right, and then our last example here, we have 16 squared minus 4 times negative 2 times negative 30. In this case, we get positive 16, which again means two distinct real. Okay, so none of these examples happen to have any where there were two distinct imaginary, but we know that when b squared minus 4ac is less than 0, that gives us the two distinct imaginary, or complex roots. All right, so for the next set of problems, these ones were actually using the quadratic formula, so we need to plug it into our formula. And the quadratic formula, remember, is negative b plus minus the square root of b squared minus 4 times a times c all over 2a. So we just need to make sure we're plugging things in the correct spot. So for a, it's going to be negative b, so negative 10 plus minus the square root of b squared minus 4 times a times c all over 2 times a. So the next step, we're going to simplify it in parts. So first part is a negative b part, so negative 10 gives me a positive 10. And then if we simplify the radical, the part underneath the radical is the discriminant. So if we put this part in our calculator, we get 20. And then lastly, 2 times 1 is 2 in our denominator. So before we think we're done, we need to see if we can simplify our radical. Well, I can actually simplify 20 as 4 times 5. And the reason we do that is because the square root of 4 is equal to 2. So I can actually write this as 10 plus minus 2 times the square root of 5 over 2. And the last thing we need to do is we need to take a look at these numbers on the outside. And if they're all divisible by the same thing, we can actually simplify this more. So 10, 2, and 2 are all divisible by 2. So 10 divided by 2 is equal to 5. 2 divided by 2 is equal to 1. And the denominator 2 divided by 2 is equal to 1, so this would all be over 1, but it's unnecessary to write that. Same way you wouldn't necessarily write 5 over 1 if you're writing 5. So our final answer is we have x equals 5 plus the square root of 5 and 5 minus the square root of 5. All right, let's take a look at b. So again, first thing we're going to do is we're going to plug it into our formula. So negative b plus minus square root of b squared minus 4 times a times c all over 2 times a. Now we just need to simplify each part. So when we simplify it down, the negative b part simplifies to positive 12. The discriminant, the part underneath the radical here, is 96, and 2 times 1 is equal to 2. So now we need to see if we can simplify our radical. So we can actually simplify square root of 96 as square root of 16 times square root of 6. And the whole reason for doing that is because 16 is a perfect square, so this actually simplifies down to 4 times the square root of 6. So we can rewrite this as 12 plus or minus 4 times the square root of 6 over 2. And just like before, if we take a look at these outside numbers, these are all, again, divisible by 2. So 12 divided by 2 is 6. 4 divided by 2 is 2. And then our denominator, 2 divided by 2 is 1, so we're not necessarily going to write over 1. So now we have our two answers. 6 plus 2 root 6 and 6 minus 2 root 6. All right, letter C. So it's going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So simplifying each part, we get 5 plus or minus the square root. This radical, or the discriminant part, is equal to 85, and 2 times 3 is equal to 6. So now we need to see if we can simplify the radical. And since there are no perfect square factors of 85, that means we can't simplify square root of 85, so this is actually going to be our answer. We have 5 plus the square root of 85 over 6 and 5 minus the square root of 85 over 6. All right, so now with letter D, so negative b plus minus the square root of b squared minus 4 times a times c all over 2 times a. We get x equals 5 plus minus this part underneath the radical here. We put that in our calculator. We get negative 87. And then 2 times 7 is 14. So now we need to simplify our radical. So looking at 87, there are no perfect square factors that go into 87. However, it is a negative, which means that we should be able to simplify it because there's going to be an I involved. So we can rewrite square root of 87 as square root of negative 1 times 87, and we know that square root of negative 1 is equal to I. So our final answer, we're going to get 5 plus or minus I times the square root of 87 over 14. So there's my two solutions. So example E, we have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this simplifies down to 8 plus or minus the square root of negative 200 over 12. Now we need to simplify our radical. Well, I know that there's a negative, so there's going to be a square root of negative 1. And a perfect square that goes into 200 is going to be 100 times 2. So negative 1 times 100 times 2 gives me negative 200. And now from here we can simplify it down. Well, we know square root of negative 1 is I. Square root of 100 is 10. And then we have the square root of 2. So we can rewrite this as 10I times the square root of 2. So simplified down, we have 8 plus or minus 10I times the square root of 2 over 12. So now that we have some numbers on the outside, 8, 10, and 12, we need to see if we can actually divide by something, and those are all divisible by 2. So 8 divided by 2 is 4. 10 divided by 2 is 5, so we have 5I square root of 2, and 12 divided by 2 is 6. So that's as simple as we can get it, and there's our two solutions. All right, now for this last one, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so now we have 6 plus or minus the square root of negative 72 over 6. Now we're going to simplify our radical. Well, I can rewrite this as a square root of negative 1, square root of 36, and square root of 2. Since negative 1 times 36 times 2 is negative 72, and we know that square root of negative 1 is I, square root of 36 is 6, and then square root of 2 can't be simplified. So square root of negative 72 is 6I times the square root of 2. Now to see if we can simplify more, we look at these numbers on the outside. They're all 6, which means we can divide them all by 6. 6 divided by 6 is 1. 6 divided by 6 is 1, so that's just 1I, or I. And the denominator 6 divided by 6 is 1, but it's unnecessary to divide by 1 since it's just the same thing. So here I have my two solutions, 1 plus or minus I times the square root of 2. All right, in this section, we are calculating each power of I to most simplified form. So what we need to know for this problem is that I to the first is equal to I squared is equal to negative 1, I cubed is equal to negative I, and I to the fourth is equal to 1. Remember that our answers can only be one of these 4 things, and that's how we simplify it. So to do that, we're going to take the exponent and divide it by 4, and to determine the rate, the remainder. So 56 divided by 4 is 14, which means I could rewrite this as I to the fourth to the 14th power. And since 4 times 14 gives us 56, we know that this just simplifies down to basically 1 to the 14th power, so our final answer is going to be 1. All right, with number 2, we're going to divide 286 divided by 4, which is 71.5, which means I can write this as I to the fourth to the 71st power. Well, that's going to get us to 284, so we need 2 more to get us to 286. This turns out to be 1 times negative 1, so our final answer is just going to be negative 1. Number 3, we're going to do 13 divided by 4, which is 3.25. So it's going to be I to the fourth to the third power, which will get us to 12, but we need 1 more I to get us to 13, so this becomes 1 times I, so our final answer is going to be I. Next one, we have 155 divided by 4, gives us 38.75. So we can rewrite this as I to the fourth to the 38th power. But that's only going to get us to 152. To get to 155, we would need 3 more i's, so I to the third power. So we know that this whole part is equal to 1, and then we know that I cubed is negative I. So our final answer is going to be negative I. All right, the next one, we're going to do 311 divided by 4, which is 77.75. So we can rewrite this as I to the fourth to the 77th power. But remember, we can look at this as our remainder, so we need 3 more i's to get to 311. So this is going to be 1 times negative I, which is going to be negative I. Next one, 180 divided by 4 is 45. And it goes in evenly, which means it's divisible by 4. So we can just write it as I to the fourth to the 45th power, which is equal to 1. So our final answer is going to be 1. 81 divided by 4 is 20.25. So we're going to write this as I to the fourth to the 20th power, and we need 1 more I to get to 81. So this is going to be 1 times I is just equal to I. All right, last one, I to the 38th power. So 38 divided by 4 is 9.5. So we can rewrite this as I to the fourth to the 9th power. And 0.5 means a remainder of 2, so I squared. So this is going to be 1 times negative 1. So our final answer is negative 1. All right, now let's look at adding and subtracting. So first we can add our real parts and we can add our imaginary parts. So in terms of real, 8 plus 1 is 9. And then 5i plus 2i is 7i. Second example, our real parts, negative 2 and negative 3, which is negative 5. And then 6 and 7, which is going to be 13. So negative 5 plus 13i. For subtraction, first thing we're going to do is we're going to distribute that negative, so minus 7 plus 2i. And then we have our real parts. 8 and negative 7 is 1. And then we have negative 4 and 2, which is going to be negative 2i. Number 7, same thing. First, we're going to distribute that negative. And then we have our real part. 7 and negative 3 is equal to 4. And 7 and 5 is equal to 12. And then with multiplying. So I'm going to go ahead and use distributive property on this first step. So 8 times 8 is 64. 8 times 6 is 48. Negative 7 times 8 is negative 56i. And negative 7 times 6 is negative 42i. Now we can combine like terms. So it's going to be 64 minus 8i minus 42, this is I squared. But remember, I squared is negative 1. So this whole thing turns to plus 42. And then we can add together our real parts. 64 and 42 gives me 106. So it's going to be 106 minus 8i. Next example, 4 times 4 is 16. Minus 16i minus 20i plus 20i squared. So we have 16 minus 36i plus 20, and we know the I squared is negative 1. So this becomes negative 20. So 16 minus 20 is negative 4 minus 36i. Seven times 3 is 21 plus 49i minus 18i minus 42i squared. So we have 21 plus 31i minus 42i squared is negative 1. So this is plus 42. So 21 plus 42 63. So 63 plus 31i. All right, this last example, I'll go ahead and do the box. 5 plus 3i, and then 3 minus 3i. So this is 15 plus 9i minus 15i minus 9i squared. So we have 15, let's see, this is minus 6i, and then minus 9i squared. I squared is negative 1. So this is plus 9. So 15 plus 9 is going to be 24 minus 6i.